Hello, my fellow developers. A few weeks ago, I came across the following question on the PostgreSQL subreddit. So the context is as follows. The user has the person table, and that person table comes with three columns. The person ID, it's a primary key, then the name column, which is indexed, and the date of birth column, which is not indexed. Then the user does this. He executes the following requests, trying to get the name and the date of birth from the person table, and the data is being filtered by the name, which is indexed, and by the date of birth, which is not indexed. So the question is how indexed and non-indexed columns work together. Does the database scan the actual table because of the non-indexed column, or does it take it from the indexed one? I can put this question differently. Will Postgres use the following name index or not for the given SQL request? And if yes, then how exactly that request is going to be executed? And many of you might be surprised to know that there is no any precise and accurate answer for this question, because it's up to Postgres to decide whether to use a given index or not. And there are several reasons that are taken into consideration. So today we will take one of the scenarios to answer this question. Will Postgres use an index or not for my query? Let's not waste a minute and do a deep dive. I'd really like to see the black screen of my terminal session, because it means that I'm about to connect to my Postgres instance. Usually I use PSQL, and an instance of the database is running on my local laptop. I use Docker, connected, and we don't have any relations. And now let's reproduce the question from PostgreSQL subreddit. I need to create the account table. And the account table will have three columns. There is ID of the integer type, then name of the text type, and also birthday, if I'm not mistaken, of the date type. Created. After that, let's use built-in Postgres capabilities to generate marked data. I will execute the following insert statement that will populate the table, ID, name, and birthday columns. The data is going to be selected from the following request. If we read from the bottom, I'm using the generate series function that will generate 100 IDs. And those IDs are going to be used as the IDs for accounts. Then I will pick one of the names for my user's random name. And finally, I will also generate some random date. Overall, let's run it, and you can see that we've got a table with 100 records. Next step, let's create an index for the named column. Created. And also I will be using vacuum analyze to force Postgres to update its statistics. Ready. After that, let's get the name and the birthday from account table for all of the users whose name is John. Okay, we've got one user. Now we are ready to ask the first question to Postgres. Hey Postgres, given that the name column is indexed, has you used an index scan or full table scan for the following request? And this question is very easy to answer, my friends. All you need to do is to run the explain analyze statement, and then you will be able to see the plan that is produced by the database. What we see, even though the name column is indexed, the database still prefers to execute the full sequential table scan. All right? Moving forward, will anything change if we update the following request to the one that was asked on the PostgreSQL subreddit? And in that question, if you remember, the user was filtering the data by the name column and by the birthday column. Let's take a look at this execution plan. The database still prefers to do the full sequential scan. Why the database is doing the full tables here when we have the index for the name column? And my guess is that Postgres is doing that because the data set is very small. We have just 100 records in our table, and it doesn't make sense to use the index. And you know what, my friend? When it comes to databases, we don't need to guess. We can easily validate this assumption. Let's do this. I will just add more data to my account table. And it's easy to accomplish with the generate series function. Let's add 10,000 more records to the database. completed. And now if I execute the same request, trying to get the name and birthday from the account for the users with the name of John and the following birthday, we see that this time Postgres decided to use a different execution plan. In particular, if we read from bottom up, I selected our index that was previously created for the name column, and then while the database was scanning the index, it was populating a bitmap. That's why you see this bitmap index scan here. What does it mean? Postgres stores all your records, all your values in pages. And that bitmap, Postgres allocates 1 bit for every page of your table. If a bit is set to 1, it means that a page stores a record value that satisfies your search condition. If a bit is set to 0 for a given page, then it means that page doesn't store any value that satisfies this condition. So eventually, the database does the index scan and populates the following bitmap. Once the index scan is over, then the database will access your table. This is why you see this bitmap heap scan. And it will be getting the data only from those pages whose bit is set to 1, because one page can store one value or multiple values that satisfy your search condition. But here is the proof is that we added much more data to our table, and this time the database decided to use the index that we previously created. And there is one more execution plan that I want to show you, my friend, before we end this video. Let's take this query and modify it as follows. I no longer want to fill the data by the birthday. I will be filtering by the name, and then I don't need to know the birthday of an account. I just want to get the name. So this is my query. I'm selecting all the names from the account table and filtering by the name column, which is index. When I take a look at this execution plan, that this time you can see that it's much simpler, and it said that Postgres performed the index-only scan using our index that we created for the name column. Why index-only scan? Because in our search condition, we are just filtering by the name column, and then as long as we are returning only the name column, then we don't need to go to the table to get the other values. The value of this column is already stored in the index, and that's why Postgres uses this index-only scan. Alright, so as you can see, depending on your data size, depending on other various conditions, it's up to Postgres to decide whether to use an index scan or to perform a full table scan. Lastly, before you go, my friend, let me leave you with a few wonderful resources that help you to learn more. The first one is an article that I produced on the similar topic, and you will find all the resources in the description to this video. This article is useful if you want to reproduce all the steps on your end. Just go to this article, copy-paste the commands, execute them, change the condition, change the data volume, and see how the database behaves. Lastly, in the end of this article, you will find the list of suggestions and resources. First, familiarize yourself with the explain and explain analyze statements. You need to know them, because depending on your data size, depending on your query, depending on indexes that you have, you will be able to answer more precisely whether the database will be using your index or not. Next, if you want to learn the basics of the indexing capabilities, I suggest you to familiarize yourself with the following resource. Use index loop. You will find a collection of wonderful articles and sections that explain you the indexing capabilities of Postgres and other major SQL databases. And lastly, if you want to do a deep dive, a true deep dive into the PostgreSQL indexing internals, then this book is exceptional. It's called PostgreSQL 14 Internals. You can get a paper version of it, or you can download a free PDF version. This one talks about PostgreSQL internals, how the database is designed, how it executes, and also there is a section that talks about various indexes and their execution plans. So hope you like this video and keep mastering databases. See you soon. Bye bye now.